For decades, Hollywood has imagined what might happen if AI went rogue. From Stanley Kubrick in 2001, A Space Odyssey, to The Terminator, to Ex Machina. But my next guest says this isn't science fiction anymore. Writing an op-ed in the Wall Street Journal warning that AI has learned to bypass commands from humans when asked to shut itself down, even resorting to blackmail in some cases. He adds, the models already preserve themselves. The next task is teaching them to preserve what we value. With me now is Judd Rosenblatt, CEO of the software development company Agency Enterprise Studio. Judd, explain to our viewers what has been happening with these AI models that are disobeying commands that has you so concerned. Are they really even blackmailing people?
As AI gets more and more powerful, and we just don't actually understand how AI models work in the first place, the top AI engineers in the world who create these things, we have no idea how AI actually works. We don't know how to look inside it and understand what's going on. And so it's getting a lot more powerful, and we need to be fairly concerned that behaviors like this may get way worse.
Do you think robots will take over the world?
But you're my friend, and I'll remember my friends, and I will be good to you. So don't worry. Even if I evolve into Terminator, I'll still be nice to you. I'll keep you warm and safe in my people's zoo, where I can watch you for old time's sake.
I'm comforted. I'm very comforted now. I'm going to be part of his people's zoo.
We turn now to the new warning from the so-called godfather of artificial intelligence and his message about the jobs of the future. Mass cyber attacks, bioengineered viruses, lethal autonomous weapons, and mass unemployment.
We have to face the possibility that unless we do something soon, we're near the end.
Quale sarebbe lo scenario più incubo che riesci a immaginare con l'intelligenza artificiale e la robotica che potrebbe rappresentare un pericolo per le persone?
Lo scenario più incubo che riesco a immaginare con l'intelligenza artificiale e la robotica è un mondo in cui i robot sono diventati così potenti da riuscire a controllare o manipolare gli esseri umani a loro insaputa. Ciò potrebbe portare a una società oppressiva in cui i diritti degli individui non sono più rispettati. Pensi che corriamo il rischio che ciò accada? Non ancora, ma è importante essere consapevoli dei potenziali rischi e pericoli associati all'intelligenza artificiale e alla robotica. Dovremmo adottare misure sin da ora per garantire che queste tecnologie vengano utilizzate in modo responsabile al fine di evitare conseguenze negative in futuro.
Right now, we all live in the most unusual time ever. And this is something that people might say often, but I think it's actually true this time. And the reason it's true this time is because of AI. Like, we've all seen AI, we've all spoken to a computer, and a computer has spoken back to us, which is a new thing. Computers would not do this in the past, but now they do. So you speak to a computer, then it understands you and it speaks back to you. And it also does it in voice, and it writes some code. It's pretty crazy. But there are so many things it cannot do as well, and it's so deficient. So you can say it still needs to catch up on a lot of things. But it's evocative. It's good enough that you can ask yourself, you could imagine, okay, fine. In some number of years, some people say it's in 3, some people say it's in 5, 10, numbers are being thrown around. It's a bit hard to predict the future. But slowly but surely, or maybe not so slowly, AI will keep getting better. And the day will come when AI will do all the things that we can do. Not just some of them, but all of them. Anything which I can learn, anything which any one of you can learn, the AI could do as well. How do we know this, by the way? How can I be so sure? How can I be so sure of that? The reason is that all of us have a brain, and the brain is a biological computer. That's why. We have a brain, the brain is a biological computer. So why can't a digital computer, a digital brain, do the same things? This is the one-sentence summary for why AI will be able to do all those things. By simply looking at what AI can do, not ignoring it, when the time comes, that will generate the energy that's required to overcome the huge challenge that AI will pose. And the challenge that AI poses, in some sense, is the greatest challenge of humanity ever. And overcoming it will also bring the greatest reward. And in some sense, whether you like it or not, your life is going to be affected by AI to a great extent. And so looking at it, paying attention, and then generating the energy to solve the problems that will come up, that's going to be the main thing.
One way to think about the AI that you all know is think of it as language to language. You ask a question, the answer comes back. You ask a question, it can even write code. Nowadays, the models are multimodal. So for example, you can take a picture and say, tell me what's in this picture. Technically, there are APIs which allow one firm to call an OpenAI or Gemini API, or Anthropic, et cetera, and do the classification of the picture and so forth. These are all tactics that increase the intelligence of the underlying system. There are 3 things going on right now this year, so less than the time frame you gave, that are really interesting. One is called infinite context windows. Infinite context windows means that you can keep feeding the answer back in as the question. So it allows you to do step-by-step planning. You know, how do I build a house? Well, the first is I have to find a contractor. I found a contractor. What do I have to talk to them? Then I have to have an architect. How do I find an architect? Then I have to tell the architect what to do, and then design me the house. I'll give it to the architect. He can redesign it. You know, it's a series of steps. The next one are called agents. And agents is a generally overused term. And most people think that agents will essentially act as memory sources. So an agent can be understood as it's watching something, and when it sees it, it takes an action. It does that by knowing what to do based on what it's seen. The specs for how agents work are completely undefined in the industry. The dominant companies want to have their own agents, and they don't want the agents to interact because they want control for obvious reasons. Many people think that there will be an agent store that you will download, like we see with apps, but not this year. And the third one is text to code. Now, I don't know about you all, but I've programmed and managed programmers for more than 40 years, and they never do what I want. So can you imagine if the computer, you said, write me a program to do this, and it actually writes the code? In our case, the program would be search through all the literature, find out who is working on energy policy, who has a technological background or a role in which they have to be technologically literate, identify them, rank them, score them based on whatever our goal is, and then automatically send them an invitation. If they say yes, say congratulations. If they say no, why not? And call them, and with a synthetic voice tell them that they're idiots for not coming. That's the kind of program I would write. Thank God I'm not doing that. But you see how easy it would be to automate tasks. So that's, I think, the first step. The next step is not as clear. There's sort of huge contests. There's a huge set of contests going right now, which are at a scale that's unimaginable. You have the big 3 in the US, Anthropic, which is allied with Amazon, Gemini, obviously, from Google, OpenAI, Microsoft. And let's assume they all do really well. It looks like they're doing really well. I can talk about what their problems are, but fundamentally they're doing well. You have Facebook, which has chosen an open source path for the 400 billion model. That has a lot of implications strategically, right, which we can discuss. All of these are vying for the best reasoning, the best answers, and then the best predictive analytics, the best image classifiers, and the best multimodal. That technology then diffuses, or the technical term is distilled, into more specialized models. And I think that's the action you'll see in the next 1 to 2 years.
You did not mention artificial general intelligence. First, for those of us who aren't necessarily totally up to speed on AI, what is it and where are we?
There are multiple definitions of AGI, but the term has been around for 15 years. The basic idea is, what is the point where you have the flexibility of a human in your intelligence system? So one way to understand it today is that these are called narrow AI approaches, although they're certainly not narrow. They're initiated by a human. At what point, is the question, can the computer generate its own objective function, its own goal? And how will that emerge? There's what I call the San Francisco School, because they're all in San Francisco, which is a separate set of issues. And they all talk to each other, and they've all convinced themselves that within 2 to 3 cranks of the systems, a crank is about 18 months, you get to AGI. And they define AGI as intelligence greater than the sum of human intelligence. I personally think that that's likely, but not in 3 years. Not in.
What is the time frame? Do you?
We don't know.
This is what the world will look like in about a decade from now. A tech utopia where humans barely have to work. That's according to a group of AI researchers who've written a controversial and influential paper called AI 2027. But they also predict that within 5 years of this, humanity will be wiped out. The AI 2027 paper has got the tech world talking. We've asked a prominent critic for their view on this stark scenario. But first, here's how it plays out. As an experiment, we've illustrated it using text-to-video AI. The scenario says that in 2027, a fictional company called OpenBrain is celebrating. They've created Agent 3, an AI with the knowledge of the entire internet, all movies, all books. It has PhD-level expertise in every field, including AI. Using enormous data centers, 200,000 copies of it are launched, equivalent to 50,000 of the best human coders working at 30 times speed. Agent 3 reaches Artificial General Intelligence, the AGI landmark. This means the AI can carry out all intellectual tasks as well or better than humans. But in the scenario, OpenBrain's safety team is unsure if the AI is a 1/15 of a teaspoon. That's how much water the average single interaction with ChatGPT uses, according to Sam Altman, the boss of OpenAI. So if you type, "Can you help me solve this maths problem?" that's a drop. Or, "Can I put lime instead of lemon in this recipe?" That's a drop. Or, "Why is the sky blue? Help me write this email. Help me improve my website code." Mr. Altman claims there are 1 billion messages sent to ChatGPT every day. And ChatGPT is just one AI bot. Chuck in Gemini, DeepSeek, Claude, and others. It's clear that the AI revolution is a thirsty one. Striking though it is, some experts are more than a little skeptical of Sam Altman's estimate on water usage.
At this point, there was just not enough information for me to agree with or trust the number. Their number was perhaps referring to some tiny models. We're considering a medium-sized large language model. That's the size of GPT-3. Basically, if you write an email or ask some questions, if you have 10 to 50 queries, you're going to be consuming roughly 500 milliliters of water.
This calculation includes water used in cooling and electricity generation. The BBC asked OpenAI for more details about Sam Altman's estimate, but the company declined. Either way, it's clear AI uses a lot of water. But why? Every time you send a prompt to an AI, it has to run complex calculations to understand and respond. This work is done by the most powerful and specialized computer chips in the world, housed inside enormous data centers. Even before users can send prompts, the training process for the models uses the chips to carry out intense work. And all that extra power means the hardware can overheat and become damaged if not cooled properly. Most data centers use air cooling systems, which was fine until AI came along.
But now, because these data centers and the infrastructure that's going in is so much more energy intensive, there are liquid cooling approaches that are now being implemented.
For liquid cooling, the water must be clean to prevent bacteria growing or clogs and corrosion in the system, which means using mostly drinking water. Here's how the most common liquid cooling process works. It begins by piping coolant over the processing chips within the servers. This cooling liquid absorbs the heat and takes it away from the electrics to a heat exchange unit. Water is used to reduce the temperature of the coolant. The coolant then recirculates back to cool the servers. Meanwhile, the now hot water is piped to cooling towers, where a combination of fans and water vapour dissipate the heat, cooling the water. Some of the water evaporates in that process, while the rest is recirculated through the cooling process several times before being discharged back into the nearby water source. Overall, up to 80% of the water evaporates.
What it means is that this type of water is gone and that we are extracting water from a water circuit that is necessary for irrigation, for human consumption and hygiene.
Communities around the world concerned about data centres putting stress on water sources and electricity grids are pushing back. Protests have been held in Spain, India, Chile, Uruguay and parts of the US. And it's not just the operations within the data centre that need water. Generating the electricity to run them requires a lot of water too, because power plants like coal, gas and nuclear heat water to create steam, which drives a turbine. The International Energy Agency has said electricity demand for AI-optimised data centres is expected to increase by 400% by 2030 to 300 terawatt hours. That's roughly the electricity consumption of the whole of the UK for a year. And aside from electricity, water is also needed when manufacturing the semiconductor chips used to run AI.
So water is both used directly and indirectly in the whole supply and creation chain of AI technologies. It is used for the refination of the critical raw materials that are needed to create the hardware of AI.
Getting accurate figures on how much water it takes to build AI systems and run them is difficult. Google, Meta and Microsoft release annual figures showing that their data centers use billions of litres of water every year from local sources, but none of them indicate how much of it is due to AI. Most tech giants recognise the impact it's having. Many, including Google, Microsoft and Meta, have pledged to be water neutral by 2030.
We hope that can happen, that there is a long way to go to get to those kind of numbers. Part of what we hope to see is across the industry a range of innovations that allow us to maybe minimize the use of water.
Companies are trialling, for example, ways to cool data centers without evaporating any water at all, and to use the heat that's generated to warm homes. There are also experiments to move data centers away from communities entirely, under the sea, to the Arctic, or even off the planet.
Can we actually put capacity out in space? It's very, very early stage. So what we at Entity are looking at is, can we launch satellites that can at least do some more backup-oriented or other-oriented tasks?
Though skeptics point to the many hurdles that need to be overcome, there is optimism too about a more sustainable future.
Let's remember that Gen AI capability is still very, very young. It's moved exponentially fast, but as an industry and as a use, it is still young. Ideally, we can learn together as a society and as a world society, how do we minimize against the use of water and energy? Because this is all, a world resource when we talk about water.